Yesterday we looked at purely resistive two ports, that is two ports containing only resistors, and analyzed such a two port and concluded that it will be reciprocal, meaning if we evaluate the y parameters, y12 will be equal to y21. Okay. And from the relationships between y parameters and z, h and g, we also know that the same thing implies, reciprocity implies z12 equals z21 or h12 equals minus h21 or g12 equals minus g21. Okay. So, we will continue to look at this and also look at the sort of circuit representation of it and circuit implication of it. It says exactly the same thing, but like I have said many times, different representations are useful in different contexts. So, y12 equals y21. What does it mean? y12 is V1, I1 by V2 with V1 being 0. This is y12 equals I2 by V1 with V2 being 0. This is y21, right. So, as you expect from the y parameter picture, you set up the circuit with two voltage sources. Okay. And now, in the first case, let us say you set V2 to 0. So, that means this is shorted, and in the other case you set V1 to 0. So, that means this is shorted. Okay. So, what this statement says is that the ratio of the current in the second port I2 to V1, so this is measuring this one, right, will be the same as ratio of this current I1 to V2 in this condition. Okay. It says exactly the same thing, but what I am trying to point out is that the problem may not be posed as a two port problem. I mean, there may not be a box with 1 1 prime and 2 2 prime marked in it. Okay. So, let us see if you understand what is going on here. Please solve this problem. I want to find the current Ix. Okay. Obviously, the circuit can be solved in many ways, and given that there is a single source, you can convert all the resistors into, combine them into series parallel combination and do something, and then use current division and so on. Okay. Or you can write this full-fledged mesh analysis equations and do it. But I was discussing something just before this, that related to the ratio of currents, right. This ratio Ix by Vx is the same as what? You have to take things in the right direction, but So, which way should the current be? Let us say I mark this current here, for this to be equal to Iy by Vy. Which way should the current be? Pointing downwards, okay? Up or down? Downwards, okay? So, you can mark these. If I call this 1 prime, then what I am looking for is Y21, right? Except of course, if this is 2 prime, I2 would be normally taken as going into the 2 port, and Ix is actually minus Y21 times Vx, okay? And similarly here, this is 2 prime, 1 prime, because I took minus Y21 Vx, I should also take in the same negative direction to the normal 2 port convention, okay? So, the point was to apply that. This is of course a purely resistive circuit with an independent source, and you have to find the current elsewhere. So, now is it easier to do this? What is the voltage here? What is the voltage here at this node? Vy by 2, and here Vy by 4, okay. So, what is the current Iy? What is it? Vy by 8 kilo ohms. So, 5 volts by 8 kilo ohms, which is 5/8 of a milliampere or 0.625 milliampere. I deliberately took something where the reverse Iy by Vy is a lot easier to calculate by inspection compared to why? So, if I consider this as a 2 port, I have to connect V1 here and V2 there, and this would be I2 and this would be I1, okay. So, in the first case, I am taking the ratio minus I2 by V1 with V2 being 0, and in the second case, I should take this will be equal to minus I1 by V2 with V1 being 0, okay. Did you get the point of this? I mean, the point was not to do circuit analysis. I assume that you would know how to analyze the circuit anyway. The point was to see that in some cases using reciprocity may be easier, okay. Is this fine? Actually, it turns out this is a very powerful theorem. It is used like this. I will try to give the context of it sometime later. It is actually used a lot in circuit simulators for various reasons, okay. Any questions about this? Now, you have to figure out the context, okay. So, if something is given, maybe the reverse direction is easier. I do not know whether it will be easier, but it may be easier. Then you have to see, okay. So, I mean, just like everything else, now when I give circuit analysis problems, I won't say, oh, solve this using nodal analysis. I will say find the answer. It is up to you what to do, okay. Similarly, here I will ask you for this. It is up to you to recognize that it is a resistive 2 port and use reciprocity if it is useful to use, okay. And in general, that is how it goes, right. I mean, when you are in primary school, the problems are really over specified. You will be given exactly what to do, and as you go further and further along, I mean, you will just be asked to find the answer. It is up to you to use all the tools that you have learned in whichever way is best to get the answer, okay. So, do not look for like template problems, right. I mean, there is one particular type of problem in the tutorial or in the textbook, and you expect the same kind of problem, that won't work. Basically, every tool that you have learned so far, you should be able to use it on any problem that you see, okay. So, in this particular case, of course, the reciprocal network is an R2R ladder driven by this side. So, it is very easy to calculate. So, it is easy to find out, okay. So, what does it mean? If I have five volts here, then the current in this direction will be 5/8 of a milliampere, okay. So, if I add a 10 volt source here, what will happen? Yeah, so what will be the answer? by 5 by 4. Obviously, you use superposition. The contribution of this alone is 5 by 8. Okay, what is the contribution of this alone? What is it? 10 by 16, also 5 by 8, right? So, you just add the two, you will get 5 by 4. Okay. So, if you have multiple sources, basically this alone, this single one, I mean the analysis of the second circuit from a single source gives you all of these, right? This was, these voltages were Vy by 2, Vy by 4 and Vy by 8. So, these currents were Vy by 4 kilo ohms, Vy by 8 kilo ohms and Vy by 16 kilo ohms. So, now if I add Va, Vb, Vc here, what will be the current? What is it? Va by 4 kilo ohms plus Vb by 8 kilo ohms plus Vc by 16 kilo ohms and so on. This is the context in which it is used most often. So, there are many cases where you have to find the contribution from many sources. Okay. One such thing happens to be, which of course you would not be familiar with now at all. It turns out that every resistor has noise. Okay. That means that the current in a resistor, if you apply a voltage across it, will be V by R, but because of random thermal motion of electrons, it will have some noise on top of it. Okay. And there are many analyses that you have to do where you have thousands of resistors and you have to find the noise contribution from each resistor. Okay. And the noise of each resistor is modeled like this. It is modeled by a voltage source in series with the resistor. Okay. So, you have 1000 resistors. Imagine that you have a circuit with thousands of resistors, and in series with every resistor you have a voltage source. You have to find how much each voltage source contributes to some particular quantity. So, let us say this current. Okay. Now, this is where the power of reciprocity lies. Instead of doing this analysis 1000 times, once with each of these voltage sources, you can do it once with a single source and find the currents in each of these branches. Okay. That will give you the contribution from the current in this branch is the same as in the reciprocal network, the contribution from Va, right, and so on. Okay. So, that is how it is used, and it is actually a practical technique that is used in circuit simulators. Okay. So, this is quite nice, but how do we handle a scenario where let us say I am interested in finding out what comes because of this current? How would you do this? Huh? So, anyway, I have already drawn the circuit representation for the interpretation of reciprocity with Y parameters. Please do the same for Z, H and G. Okay. Please draw these equivalent circuits and see what is it that you get. You have a 2-port network. You apply I1 on one side and measure V2 here with open circuit on that side. So, here we are measuring V2 by I1 with I2 equal to 0, basically Z to 1, and that ratio would be the same as if you applied a current here and measured V1 with port 1 being an open circuit. This is Z12. Okay. So, again, that is in a circuit, if you see that you are you have a current source and you have to measure a voltage here, you have to consider, maybe it is easier to apply a current source here, measure the voltage here, the ratios will be the same. Okay. If it happens to be easier to work the reverse problem, that is a useful technique. Okay. Whether it will be useful or not, I don't know. That depends entirely on the circuit. Okay. And similarly, if you have multiple sources, it may be useful. You can, if you have multiple sources and you want to find the response at a single port, you can apply a single source and find the response in multiple branches, and the results will be the same if it is a reciprocal network, that is a purely resistive network. Similarly, H12 equals minus H21. In this case, how do you measure H21? What will you apply? How will you measure H21? What is it that? Yeah, I will apply a current here, I1, and measure the current I2. So, H21 is the short circuit current gain, right? You from port 1 to port 2. And that will be equal to what? Minus H12. And how do you measure that? You apply a voltage source to port 2 and open circuit port 1, and you measure the voltage gain. Okay. Okay. And these two will be equal to each other with a change of sign. Okay. An example of this we already saw, okay, with G parameters, but the voltage and the current dividers, right, they are the converses of each other. Essentially, the transconductance, that is the ratio of current to voltage, you apply a voltage, measure the current here, that will be the same as applying a voltage and measuring the current on this side. Similarly, the transimpedance, that is from Z parameters, you apply a current here, measure the voltage here with an open circuit, that is the same as applying a current here and measuring the voltage on this side. In every case, you have two sources and you set the sources to 0, you do not remove it or do anything arbitrary with it. Okay. Or you measure a current gain, you apply a current here and measure the current in this port, that will be the same as the reverse voltage gain. You apply a voltage here and measure the voltage here, except for a reversal of sign. Okay. I mean, we always, all our currents and voltages are denoted by passive sign convention. With that, you will get a negative sign in this one. Similarly, if you change the designation of port 1 and 2, you will get the corresponding thing for G parameters, right. G12 is minus G21. G21 is measured as a voltage gain. You apply V1, open circuit port 2 and measure V2. So, this is the open circuit voltage gain from 1 to 2, and that ratio will be the same as the negative of the current gain, the short circuit current gain in the opposite direction. Okay. Is this fine? Any questions so far? So, if you have a resistive network, it will be reciprocal. What it means is some symmetry in the two port parameters, okay, which can be interpreted as the gains from port 1 to port 2 or port 2 to port 1, they will be related to each other in a reciprocal network. In a non-reciprocal network, of course, they will not be related to each other. Okay. So, this is useful for analysis. As well as sometimes it turns out that let's say you want a certain kind of function, you want to realize it in the forward direction, it may be difficult, in the reverse direction it may be easy, and so on. So, it is also useful for design in some cases. Any questions so far about reciprocity? Okay. I want to find the current here Ix, and I have a 1 milliamp current source there. What is the answer? This in fact is slightly messy to do if you try to do parallel series combination of resistors. In this case, reciprocity really helps. But what will you find to solve this by reciprocity? You have to find some, I mean, what is asked for is a current gain, right? You are given a current source and you are asked to find a current. So, essentially you are asked to find a current gain. So, what should you find instead? Huh? What will you find instead? Voltage gain in the opposite direction. So, if I designate, let us say this is port 1 and this is port 2, okay. So, what is asked for is I2 by I1 with V2 being 0, okay. So, instead what will you find? It is equal to what? The same thing is equal to minus V1 by V2 with I1 being 0. So, I1 being 0 means you just open circuit this, okay, and you have to measure V1, that is between these two terminals, okay, and you have to apply a voltage V2 there, okay. So, what is the voltage between these two terminals? If you think of this as the reference node, what is the voltage at this terminal? What is it? V2 by 4, and here V2 by 8, and here it is V2 by 16. So, what is the voltage V1? V2 by 4 minus V2 by 16. How much is that? 3 by 16 times V2. Okay. So, what is the current Ix? What is it? Minus 3 by 16. I think many of you have got the answer 3 by 16, but without the minus sign. Please mind the signs. Okay. So, this current is minus 3 by 16 milliamperes. Okay. So, this is how you could use reciprocity, right. Again, you have to keep in mind that it may make it convenient, it is not necessary. Who knows, maybe the straight network is easier to analyze than the reciprocal one, but it is possible that it is convenient. It is also especially useful if you have multiple sources and you want to find the response at a single point, and that is a single voltage or a single current. Okay. Any questions? Purely resistive two ports are reciprocal, and which means that this follows all these say the same thing basically. Okay. Any questions about reciprocity? Yeah. No. I1 is not equal to I2. If you short circuit port 2 and apply voltage only to port 1, and in the other case you short circuit port 1, apply voltage only to port 2, these ratios are equal. Okay. In a general case where you have some V1 and some V2, okay, you can't say what is the relationship between I1 and I2. That depends on the other parameters as well, the actual values of Y11, Y12 and Y22. Is that what you are asking? No. So, the power delivered by this is V1 times I1 in this circuit. Okay. So, let us say we keep the same voltage here. Let us say we have 1 volt here and 1 volt here, right. The power delivered here is 1 volt times I1. The power delivered here is 1 volt times I2. Okay. There is no reason for these two to be equal. Okay. In this case, this I2 in this circuit will be equal to I1 in the other circuit, not this I1 and that I2. Okay. There is no relationship between, that is necessarily enforced between Y11 and Y12, sorry, Y11 and Y22. Okay. Any other questions? So, the measurement conditions are different for the two. Please keep that in mind. Okay. Anything else? We can go back to very basic 2 ports which we have studied elsewhere, which are control sources. And if I take a voltage controlled voltage source, that is also a 2 port, right. There are 2 ports. If I call this 1 prime, that is the controlling voltage, and the controlled voltage, let us say I call that port 2, and that is K times Vx. Okay. So, obviously, this is a 2 port and it can be described by 2 port parameters. So, which parameter set would you use to describe this? I asked you to evaluate all this yesterday, right? Huh? The dependent variable V2, and which should be the independent variable V1. So, V2 is K times V1. So, at least from the relationship it should look like you should pick a parameter set where this is the dependent variable and that is the independent variable, and which is that? G parameters. Okay. So, I1 V2 equals the G parameter matrix times V1 I2. So, what will be the 4 parameters? What will be G11? What is the value of G11? 0. I1 itself is 0, right? No current flows here. So, both these, this is 0 independently of V1 and I2. And what is G21? That is the voltage gain K. And what is G22? What is G22 actually? How do you measure it? You basically open circuit this and then you find the resistance looking back to this side. So, that will be 0. Okay. And in fact, you can try to measure any of the other parameters y, z or h. What will happen? at least one of the parameters will come out to be infinity. Okay. If you want to measure y parameters, how would you measure it? You short circuit port 2 in some case and apply a voltage here, but then you are short circuiting a voltage source. You can't do that. Okay. Infinite current will flow. So, that is true for all three. Something or the other will be a problem. I mean, you can't measure Z parameters because you can't push a current into an open circuit. Okay. And similarly for H parameters. Yes. Why is? No, that's the definition, right? Because this is this voltage controlled voltage source. All it does is it senses the voltage between two nodes. Okay, some two nodes in the circuit. So if I have to represent it as a two port, this doesn't add anything. Okay, what I mean is, let's say I have some circuit with some two nodes and it has Vx between them. Okay, and it enforces K times Vx between these two other nodes, right? So now, if I have to think of this as a two port, there is nothing here. This is not drawing any current, because if I connect the two port with, let's say, some element here, that will actually change the circuit. Okay, that will add something between these branches. Actual circuit, that that may or may not be the case. There may or may not be something between the two, right? I mean, who knows like what is there between the two. If you want to treat this as an element independent of everything else, this the definition of this should not depend on, in a particular circuit there is some resistance between those two terminals and so on, right? It should be independent. And actually there may not be, okay, these two nodes for instance could be like some separated nodes, there may not be a single element between them. So, no, not a current in this. In the remaining elements connected in the circuit there will be current. Okay, there could be, who knows, something else connected here, right, outside of this. There can be a number of things connected here, but that is not part of the voltage controlled voltage source. Okay. So, the definition of the voltage controlled voltage sources, it simply senses the voltage and then provides another voltage which is a scaled version of it. Okay. I will think about it, I mean that's we can discuss that further. Similarly, if you have a voltage controlled current source, this should be pretty obvious. What is the parameter set that can be used to describe this? It looks like the equivalent circuit of some parameter set, right? What is that? Y parameters, right? So, this has I1, I2 equals the Y parameter sets times V1, V2. And what are the parameters? What is Y11? What is Y11? 0. No current flows, right, into this. So, this is 0 and this is also 0. What is Y21? That is the GM. Okay. And what is Y22? 0 also, because if you short circuit this current source becomes 0, it becomes an open circuit, 0. I mean, now you should see the pattern. You do it for the other two, it will have only the forward parameter, right? Is this reciprocal? Is this element reciprocal? Clearly not. In fact, it is unilateral. It has control flowing only in one direction, right? Because, I mean, that is what we wanted from the ideal control sources. You have some quantity here and the quantity on port 2 should be related to this, okay? And it is unilateral in that this is the cause and this is the effect, okay? Now, you have to not get confused between doing calculations and the cause and effect, right? I mean, here also, for instance, in a problem, you could be given that, hey, this is 5 volts, find out that voltage. That can be easily done by algebra, right? 5 divided by k is that voltage. But it doesn't mean that you can apply 5 volt to this side and 5 by k to the other and get 5 by k from the other side, okay? You can apply a voltage to port 1 and get something at port 2, right? Cause and effect are different from doing calculations. You can calculate the cause from the effect, by knowing the relationships, but you cannot apply something to this side and get something on the other side. Okay. So, it is very important to make a distinction between these bilateral elements. If you have a resistor, you can apply a current and get the voltage, or you can apply a voltage and get the current. Okay. That is a bilateral element, whereas this is definitely not that, right. You can't apply something to the right side and get something to the from the left side. Okay. So, the left side is the cause and the right side is the effect.